It's just another busy workday, filled with the usual hustle and bustle, the endless congestion, and the close calls and near misses that people around the world have come to accept as part of everyday life. We navigate through our days, oblivious to the unseen dangers lurking in the cosmos. But on June 5, 2020, something extraordinary happened. High overhead, hidden behind the blinding light of the sun, an asteroid large enough to destroy an entire city was hurtling towards Earth. This asteroid, named 2020 LD, came from behind the sun faster than a speeding bullet. It passed within less than 4/5 of the distance to the moon, and no one saw it until 2 days later when it emerged from Earth's shadow into the night sky, moving away from our planet. This event serves as a stark reminder of how vulnerable we are. Earth is 66 million years overdue for an asteroid attack similar to the one that wiped out the dinosaurs. We are relying solely on luck for survival, and the apocalypse never seems far away. The asteroid was quickly identified as a near-Earth object with a diameter of about 140 meters. Near-Earth objects are asteroids or comets that pass close to Earth's orbit. If an asteroid passes within 45 million kilometers of Earth, it is classified as a near-Earth object or a near-Earth asteroid. Asteroid 2020 LD passed within 307,000 kilometers of Earth at a speed of around 27 kilometers per second. Had it struck the planet, it could have easily wiped out an entire city with its mass and velocity. To put this in perspective, the asteroid that struck near Flagstaff, Arizona, 50,000 years ago was about 46 meters and hit at a speed of 15 kilometers per second, far less than the 2020 asteroid. Compared to the recent Chelyabinsk incident in Russia on February 15, 2013, which caused 1,300 people to seek emergency medical help, the damage potential of asteroid 2020 LD is much more alarming. Even though we are getting better at detecting distant objects, detecting asteroids in close proximity to Earth remains a daunting task. As of today, only 5 asteroids have been discovered before impacting Earth. This difficulty arises because asteroids are much smaller than stars or planets and barely reflect any light. Moreover, most asteroids are detected using ground-based telescopes, which are limited by climatic conditions. If an asteroid poses a threat on a cloudy day, we might be out of luck. Space observatories, although technically advanced, are designed for deep space imaging and cannot discern objects so close with current technology. NASA scientists can estimate the orbit direction of asteroids with some certainty for the next 100 years. However, asteroid trajectories are extremely erratic, influenced by the Sun, planets, and their initial orbital velocity. Even a small error in trajectory prediction can lead to major inaccuracies, potentially costing humanity dearly. The hunt for asteroids began recently. The first ever asteroid discovered was by Giuseppe Piazzi in 1801. He named the 1,000-kilometer-wide asteroid series, later classified as a dwarf planet. Since then, millions of asteroids have been discovered, mostly between Mars and Jupiter in the asteroid belt. While most asteroids remain in this belt, some drift towards Earth, posing significant risks. As of today, 27,440 near-Earth objects have been discovered, including 117 comets and 27,323 asteroids. Out of these, 2,270 are considered potentially hazardous asteroids, PHAs. A PHA is an object capable of making close approaches to Earth and is large enough to cause significant regional damage in the event of an impact. Approximately 150 of these are estimated to be larger than 1 kilometer in diameter. Is it possible that an asteroid of this scale could strike Earth and wipe out the human race? To answer this, we must examine past asteroid impacts. While Earth has been struck by asteroids as frequently as the Moon, perfectly preserved craters on Earth are rare due to natural erosion and blending with surroundings. The Torino scale was developed to study the impact risk posed by asteroids, ranging from 0, negligibly low probability, to 10, collision unavoidable and catastrophic. The Chicxulub event, which wiped out the dinosaurs 66 million years ago, is the most infamous asteroid impact. It caused a cosmic winter, leading to mass extinctions. More recently, The Tunguska event in 1908 in Siberia was a massive explosion caused by a 90-meter-wide meteor, comparable to a hydrogen bomb, destroying 18 million trees over an area the size of Rhode Island. Large asteroids, over 10 kilometers in size, strike Earth approximately once every 66 million years. Congress directed NASA in 1998 to locate 90% of these dangerous near-Earth objects. Asteroids like Bennu and Apophis are monitored closely. Bennu, with a 1 in 1,750 chance of colliding with Earth in the next 3 centuries, and Apophis, which will pass very close to Earth in 2029, are of particular concern. NASA has developed plans to mitigate asteroid threats, including the DART mission, which successfully altered an asteroid's course in 2022. Other strategies include gravity tractors, nuking asteroids, or using solar energy panels. However, these are only safety nets, and the vast number of meteors and asteroids makes it a game of whack-a-mole.in. Conclusion: while the risk of a catastrophic asteroid impact exists, scientists believe other threats like climate change, artificial intelligence, biological warfare, global pandemics, or nuclear conflict are more immediate. Continuous efforts by space organizations highlight our small yet significant role in the cosmic scale. While NASA has not discovered any asteroid large enough to directly endanger Earth yet, the big one may still be out there, waiting to be discovered. Until then, we continue to prepare and hope for the best. But what if the big one does come? Imagine an asteroid 10 kilometers wide, categorized as an average of 8 on the Torino scale, is about to impact Earth in the near future. Present asteroid avoidance missions would become pointless since humanity has never practiced for a catastrophe of this magnitude. The asteroid would slam into Earth, leaving humanity with little to do except watch the countdown before the impact. Where the asteroid strikes would determine the majority of the destruction. An impact above London would instantly destroy everything in the United Kingdom, France, Ireland, Belgium, Switzerland, Germany, and Denmark. People within this 100-kilometer-wide crater would quickly vaporize due to temperatures equivalent to the sun's surface. The raging pit would be large enough to swallow the entire big island of Hawaii. Fortunately, only 3% of the planet's land is densely populated, meaning that if an asteroid strikes a city, it would be the worst day in human history. If you haven't looked for bunkers nearby, now is probably the time. Outside of this circle, people would need to immediately flee to their closest bunkers, each stocked with at least 6 months' worth of supplies. The internet would stop working as the city's infrastructure collapses. Those unable to find shelter would experience the brightest flash of light in human history, unaware that they would be annihilated in seconds. Global tsunami waves would reach heights of up to 300 meters, about the height of the Eiffel Tower. Massive wildfires in at least half of the world's forests would cause the extinction of most species, especially those already vulnerable. The Earth would rumble with an earthquake reaching a massive 9 on the Richter scale, the strongest in the last 150 years, causing remaining buildings to collapse. But the worst is yet to come. Due to the high-speed collision of the asteroid with Earth, thousands, if not millions, of massive chunks of land and rock would be catapulted into the atmosphere. While some would escape Earth's gravity, many would return to the surface at incredible speeds, causing a second round of asteroid strikes. For the next 30 minutes or so, it would rain mountains. If your bunker survives this overkill, you'd be quite lucky. Approximately 6 hours later, the rock rain would stop, making it possibly safe to exit the bunker and observe the devastation. Everything would be unrecognizable. The entire planet has practically been turned upside down. Your favorite restaurants, hotels, and attractions would be buried under layers of ash. The entirety of human history would lie beneath this thick layer. A thick layer of smoke and dust would quickly envelop the globe, blotting out the sun. An impact winter could last for months or even years. Sunrise and moonlight would become things of the past. Without photosynthesis, most plants would die. Plant-eating animals would die out, and the animals eating those animals would follow. Probably the only organisms remaining would be extremophiles, creatures that thrive in the harshest conditions. Tardigrades, for example, are capable of surviving multiple harsh conditions. They can curl up into a dry, dead ball, lasting for decades in cold, dry settings like space. As for humans, it would be a close call. Darkness, freezing cold, and global famine would throw the world into chaos. Our final hope for re-establishing society would be the little communities living in underground bunkers. This would not be the end of the world, but it would probably seem like it. Despite the looming threat of asteroid collisions, scientists claim that other dangers are more pressing. Climate change, artificial intelligence, biological warfare, global pandemics, and nuclear conflict pose significant risks to humanity. Anthropogenic risks are seen as more plausible than a doomsday asteroid attack. Experts believe that the apocalypse may not come from a swift blow but from a gradual decline, one disaster bleeding into the next until humanity fades away. Whatever the case, it won't take place soon. After all, we've made it this far. Millions of years of evolution, countless disasters, and humanity is still standing. Space is undoubtedly one of the realms that inspires both terror and hope at the same time. Continuous efforts and studies by worldwide space organizations demonstrate how small we are on the cosmic scale, yet large enough to avoid such catastrophic disasters. It's truly a miracle how far we've come. While NASA is constantly looking for asteroids, it hasn't discovered any that are large enough to directly endanger Earth yet. However, there is still a lot of space to survey, and the big one may be on its way. We simply haven't discovered it yet. So, when is doomsday? Maybe we don't know. Perhaps we'll never know until a giant rock comes from behind the sun, hurtling towards Earth, only this time hitting it directly. Until that day comes, humanity continues to look to the stars not just with fear, but with curiosity and ambition. Our exploration of space has led to incredible technological advancements and a deeper understanding of our place in the universe. We are learning more about our solar system, discovering new planets, and even sending missions to distant worlds. The story of humanity's relationship with space is one of resilience and determination. Despite the risks, we continue to push the boundaries of what is possible, dreaming of a future where we might colonize other planets and protect our species from extinction. Our efforts to detect and deflect potentially hazardous asteroids are part of this broader quest for survival and knowledge. The challenges we face on Earth, from climate change to pandemics, remind us that our survival depends on our ability to adapt and innovate. Space agencies around the world are collaborating, sharing data, and developing new technologies to protect our planet. These efforts not only help us prepare for potential asteroid impacts but also enhance our ability to respond to other global threats. As we gaze up at the night sky, we are reminded of our fragility and our strength. We are but a small part of the vast universe, yet we possess the ingenuity and spirit to face the unknown. The story of Asteroid 2020 LD is a reminder of the importance of vigilance and preparation. It challenges us to think about the future and what we can do to ensure the safety and prosperity of our planet. So, while the threat of an asteroid impact is real, it is not the only challenge we face. It serves as a metaphor for the many obstacles humanity must overcome. Our ability to detect, understand, and mitigate these threats will determine our future. The lessons we learn from space can help us address the challenges on Earth, fostering a sense of global unity and cooperation. In the end, the greatest lesson we can take from the story of Asteroid 2020 LD is that we must always be prepared, always vigilant, and always hopeful. Our journey through the cosmos is just beginning, and with each new discovery, we learn more about ourselves and our place in the universe. The future is uncertain, but it is also full of possibilities. As long as we continue to explore, to innovate, and to dream, there is hope for a bright and prosperous future for all of humanity.